Here's a question for you. Why doesn't the moon come crashing out of the sky onto the Earth? Is it because of the Earth's gravity? Well, it cannot be because gravity pulls everything down, but the moon is holding up like it's being acted on by some other kind of force. Also, why is the moon moving in a circle around Earth? From Newton's first law of motion, things usually like to go in a straight line. But the moon is not actually doing that, is it? It was around the 17th century and Newton was puzzled by these two questions about the moon's orbit. This was a big deal for him because he had just figured out that gravity, and now needed to figure out how all the stars and planets up in the sky were moving around. And it took Newton over 20 years to figure this stuff out. And of course, he had to invent calculus along the way, which is no small feat. But thanks to his genius thought experiment, we can wrap our heads around it in little less than 20 years. His thought experiment is called Newton's cannonball. You can think of a thought experiment as a mental exercise where you explore some hypothetical scenario. Thank goodness all that stuff's just in your head, no need to actually do any of it in real life. For this thought experiment, picture yourself standing on top of a gigantic, massive mountain. But this isn't just any ordinary mountain. It has an enormous cannon at the top. One so unbelievably powerful that it can blast a cannonball with enough force to break free of the Earth's gravity and soar all the way to the moon. However, because Earth has a gravitational pull, the cannonball would follow a curved path and fall back down to the Earth. If you pick the right velocity, known as orbital speed, the trajectory of the cannonball would curve at exactly the same rate the Earth curves, and therefore the cannonball would always stay at the same height above the ground. It will go on circling around the Earth along a fixed circular orbit just like the moon. Therefore, the moon is falling down to Earth, but just like the cannonball with large speed, it goes circling around the Earth rather than coming crashing onto the Earth. So, it is the right balance of the forward velocity of the moon and Earth's gravity that fixes the moon in its orbit. Without Earth's gravity, it would go wandering in the universe, but the force of gravity pulls it. However, the moon has its own forward velocity which makes it move in a circular path around the Earth. Now, you might be wondering what causes the moon to have that enormous speed in the first place. There are several hypotheses for that. As the moon formed, the material that eventually coalesced into the moon spun around the Earth. This spinning motion created an angular momentum, which has to be conserved, which meant that the moon had to be set in motion around the Earth. This resulted in its initial speed. Overall, the moon's initial speed is the result of a complex interplay of gravitational forces, angular momentum, and other factors related to the formation of the solar system.